Hey guys, it's Chris. Welcome back to another episode of the Weekly Coder. In this episode, we are going to continue where we left off with our Pac-Man clone. If you'll recall, the first part of the tutorial series was to basically just add in all the graphics and create the maze and drag Pac-Man into the scene. So this is where we all should be at this point, is to have basically our entire game board set up, right? So, what we're doing today in this tutorial is we're going to first, we're going to animate Pac-Man, okay? And this is a very, very simple animation. All he's going to do is open and close his mouth. And there are 3 frames total, so I'm going to show you how to use the legacy animation system along with Mechanim to... actually, we're not going to do a whole lot in Mechanim, other than setting our default animation to be... Well, no, we're probably not even going to get into Mechanim at all, because we're going to create the animation, and that's just going to be that. It's just going to have that continuous animation of him opening and closing his mouth. So like I said, those animation frames, there are 3 of them. One where he's closed, one where his mouth open a little bit, and one where it's open all the way. And then that animation is just going to loop over and over and over and over. We're going to set the animation frames at 0, 5, and 10 frames. Okay? So the other part of this tutorial is going to go into detecting user input using the keyboard, and just very, very simple movement and direction. Basically, how we're going to know which direction to face Pac-Man depending on which direction he's going in. This isn't going to be the tutorial that shows you how to keep Pac-Man within the maze. Basically, he's going to have no constraints, and he's just going to move in the direction that we tell him to. But that will be the foundation for that we're going to use to build the rest of the functionality into the Pac-Man script. Right? So, let's go ahead and get started with this. What we're going to do before we do any coding is we're going to create this animation. And what we're going to need are some more graphics, because right now all we have is Pac-Man with his mouth closed. So I'm going to have another set of graphics for you guys to download. Let me just find where I put those. Okay, there we go. So I've got a Pac-Man 2 and a Pac-Man 3 PNG file that I'm going to drag into the graphics folder. Alright, and as you can see, we've got closed mouth, somewhat open, all the way open. Alright, so let's go ahead and set the graphics properties on these. Let's see, what did I do here? 16 pixels per unit, and we should have set the filter mode to point. Alright, so we'll do the same thing here, 16 and point. Alright, so these are ready. So all we're going to do is we're going to click on our Pac-Man game object to select that. Okay. Right. And then we're going to open the animation window, and the way we do that is we just go up to Window and go to Animation. And I don't know how this is going to pop up for you guys. For me, it's just a separate standalone window. You can, of course, just drag it up here if you like and work with it that way, or you can detach it completely. It's completely up to you. So since Pac-Man is selected, the animation window is telling us to begin animating Pac-Man, create an animator and an animation clip. So we're going to go ahead and click the Create button. And here it says New Animation and Where in Graphics. So, you know, let's cancel out of that for a minute and let's create a new folder and call it Animation. Animations. Okay. And let's go ahead and click the Create button. And we'll call this just Pac-Man Animation. And we're going to put it in Assets, but we're going to be putting it in Assets under the Animations folder. And hit Save. Okay. So now we've got our timeline. And what we need to do is we need to add a property to our game object that we want to animate. Okay, so we're going to click on Add Property, and here we're going to go to Sprite Renderer since we want to modify the sprite, and we're going to select Sprite because that is the actual component that we want to modify on this game object. So we just click the Add button. So now we've got this Pac-Man sprite component in our animation window that we can add frames to. So you'll notice that we've got all the way from 0 to 1 minute. We're not going to even have that many frames. So first we're going to delete this one. So click on it, press the delete button, and we're going to have this guy starting at 0. And let's zoom in. Okay, zoom in all the way. So now we've got basically just frames 0 through 10 in our view. Okay, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So what we're going to do is we're going to go into the graphics folder. We're going to grab Pac-Man 2. I'm going to set him over here at the 5 marker. And then we're going to grab Pac-Man 3, set him over at the 10 marker. Okay? So now if we play this, it's just going to loop continuously from open to close. Open to close. Okay? So let's go ahead and click the record button to stop recording the animation. And let's go back to our scene and let's go ahead and click the play button. Alright, so we now have this open close animation for Pac-Man, which is kind of cool, right? Because that's really all it took is to do that animation. So, you know what we could do to make this animation look a little smoother? So if we go back into animation and add another frame of him halfway closing his mouth at 15, then this should look a little better. So let's have a look here. Yeah. Okay, that's way smoother. That's awesome. That looks good. Okay, so just to kind of give you guys an idea of what happened when we created this animation in the animations folder, we created this right here, which is Pac-Man animation.anim, which is the actual animation. And then we've got this animation controller, okay? And that you can go, if you're in the Mechanim animator, if we had more than one animation, we wouldn't just have this Pac-Man animation here. We would have, you know what? Eventually we're probably going to do a second animation, which is going to be of Pac-Man dying when he gets hit by a ghost. So, you know, that would be one thing. And then we would have that animation over here. And then we would create transition states between these animations and set variables so that if, you know, a certain condition is true, then it would transition from this animation to the dying animation, perhaps. Okay? So that's all I'm going to get into right now that has to do with Mechanim. So we're going to just, you know, X that for now. We're not going to even worry about animator or animation since we're done with that. So we're going to go back into our scene view and just press play one more time because our animation is so super cool, right? Look at Pac-Man. He's just ready to go. He's ready to go, but he can't because we have no way of telling him to do it. We can press all the buttons we want, but Pac-Man just doesn't want to go. So what we've got to do is we've got to create an input method so that when the user presses a key, that it will initiate Pac-Man to start moving, so that he can start, you know, obviously eating because he's just chomping down, he's ready to go, and yeah, he can't. So, to keep things simple, we're going to go to script. We're going to create a new script, C# script, and we're going to just call this Pac-Man because, you know, that's who it's for. So before we start coding this, let's go ahead and attach this to the Pac-Man game object. So we just click on Pac-Man here in the hierarchy. Then we drag the Pac-Man C# script over onto the inspector window, and now we've got our script attached. All right, so let's go ahead and launch that. And as always, we've got the usual stuff. You know, the namespaces. We've got our class. And then we've got our two methods, start and update. Okay. So the first thing we are going to want to do is we are going to want to keep track of input, right? So we're going to create a method, and we're just going to call it check input. Okay, and before we get ahead of ourselves, let's go ahead and go into the update method and call this check input method. And you know, the update running every frame like it does will go ahead and call this check input method at every frame. So at every frame, we are going to check to see if the user's pressing a key. So, yeah, let's go ahead and do that. Let's see here. All we're going to deal with is left, right, up, and down, because that's the only movements that Pac-Man actually has. So to do this is very simple. We're going to do if input dot get key. We're going to say get key down. So as soon as the user presses the key, Pac-Man will move. Okay, so if input get key down, key code dot left arrow else if input get key down, key code right arrow else if input get key down, key code dot up arrow else if input dot get key down, key code dot down arrow. Okay, so these will check to see which keys are pressed, and yeah, so then from this point we actually need to tell Pac-Man to move, and we need to tell him to move in a specific direction. So directions in 2D games are based on an XY grid. So you've got X, which is the horizontal position, and you've got Y, which is the vertical up and down position. So we are lucky enough to have a vector 2 that we can utilize for that, and vector 2 has some properties that are going to be very useful. Vector 2 we can call a vector 2.0, vector 2.up, vector 2.down, vector 2.left, vector 2.right. And all these are differences. So like vector 2.0 would be x equals 0, x or y equals 0. And vector 2.left would be x equals -1, y equals 0. So those directions are predefined, which makes it a little easier for us. I mean, we could create new vector 2s and just put the x and y coordinates in, but you know, since we have these available to us, we should just go ahead and use them. So we're going to create another method, and we're going to call this void move, and we are going to pass in the direction that we want to move. So vector 2, and we're just going to call this D. Okay, and let's go ahead and do this. If left arrow, so we're going to move Pac-Man to the left, so we're going to say move and vector 2 dot left, and here we're going to do move vector 2 dot right, and here we're going to do move vector 2 dot up and move vector 2 dot down. Okay, so well, that's all good and well. So now we know which direction we want to move. We're calling a method stating which direction we want to move. So in this method, we need to actually make the move happen. And to make the move happen, we are going to need to define something. You guys, guess what that is. We need to move Pac-Man. So he has a direction, but he has no speed. So if we tell him to go left, if we don't tell him how many pixels we want him to move, or units to move into the left or right or up or down, then he's just going to stand still and not go anywhere. So we need to define a variable. We're going to call this one speed. we'll do a public variable so that we can modify that in the inspector. And we are going to set our speed variable. Let's go ahead and set our speed to 4.0f. Okay. Public speed. Okay, well, yeah, I'm not thinking, clearly not thinking this morning. That's going to be a float. Public float speed. All right. So now, all we have to do to implement this speed is we're going to take the local position of the transform of the game object that the script is attached to, which is Pac-Man. So we're going to say transform local position equals, okay? So we're going to take his local position and we're going to set it equal to something else, right? So we're going to do a new vector 2, and we're going to pass in, actually, we're going to just do actually what we'll do is instead of just setting the local position equal to something, we're going to do plus equals, which actually takes it from where it's at now and adds to it the amount that we want to move. Okay, make more sense, right? Otherwise, we'd have to add our local position to whatever position we want to move in order to get to where we want to go. So this plus equals makes it better. It makes it better. Oh my god. Yeah, I'm a little sleepy this morning. So anyways, transform.local position plus equals the direction, okay, so this is a vector 2 times speed times time.delta time. Okay, so yes, we can multiply a vector 2 times a float, and what happens is when we multiply a vector 2, since it's got x and y values, both of those values will be multiplied by speed. So let's say we've got our direction vector 2.left, which is x equals -1, y equals 0. -1 will be multiplied by our speed, which is 4. Okay, so we've got 4 times -1, which will give us -4. And then we're going to multiply y, which is 0, so 4 times 0 stays at 0, which is perfect. And that's all we really need. So this should move Pac-Man. Yeah. So let's give it a shot. And we have a compiler error. What? Okay. Oh, because local position is a vector 3 and we've got a vector 2. So we're gonna have to cast a vector 3 there. Okay, so Pac-Man's standing still. Now we're gonna go right. And yeah, so I didn't really think this through. What's happening is because it's only moving on key down. So what we're having here is Pac-Man will only go every time that we press the key down, which is going to be insanely irritating. We'll never escape the ghost this way unless you can click really fast, which in this case, you can't click 30 frames per second to get that move speed that we want. So let's go back into our script and fix that. So vector 2.left. So instead of passing in which direction we want to go, how about we create a variable that will tell Pac-Man which direction he's always supposed to be in. So let me just bear with me for a minute here. I'm going to create a variable, and we're going to make this private because it doesn't need to be accessed, and we're going to call this direction. Okay. No, we're going to call it direction after we tell it what type it's supposed to be. And the type is going to be vector 2. So we're going to call this direction. And we're going to set it equal to vector2.0 initially, because we don't want Pac-Man to go anywhere. At some point we do, but right now we'll just make him 0. So then what we'll do here is, instead of calling the move method, we'll just vector2, so direction equals vector2.left, direction equals vector2.right, direction equals vector2.up, and finally direction equals vector2.down. Okay, so what we're doing is we're essentially assigning the direction depending on which key is pressed. So if we press the left arrow, then this variable, this direction variable, will always equal vector2.left until we press a different key. So now, instead of, let's see here, we'll just get rid of this. So we'll just make the move a void function that has no parameters, and we're going to call move after we call check input. So move is going to get called 30 frames per second. So then we've got transform.localPosition plus equals. We can't use D anymore, but we will use direction. So we'll use direction times speed times time.delta time, which is going to update every frame 30 frames per 60 frames per 60 frames per second. All right, so we're going to go ahead and give this a shot. So now let's press play. Okay, so now when we press right, Pac-Man moves right. He goes through the entire maze, which is pretty cool. And left will make him move left, and we've got up, which will make him go up, and down, which will make him go back down. So we can move Pac-Man anywhere on the screen that we want to move him, which is pretty neat. If only the game were like this, it would be so much easier, because there's a ghost chasing you and you just disappear through the wall, which is kind of cool. So let's go ahead and stop that, because we're going to have to move along and get to the next part. And that part is going to actually be to rotate Pac-Man depending on the direction that he's going in, right? So that's actually going to be pretty simple. What we're going to do is we're going to create another method, and we'll call this one update orientation. And we're not going to have to create any parameters here either, because orientation is going to just be updated depending on the direction. Okay, so we're going to call update orientation here in our update loop. So every frame, this update orientation method is called and is going to be checked to see what the orientation should be. So very simply, we just do a couple of if statements. If direction equals vector2.left, else if direction equals vector2.right, else if direction equals vector2.up, else if direction equals vector2.down. Okay, so we've got our 4 directions. All right, so if we're going left, you may have noticed in the graphics, well, I can't show you here, but Pac-Man is initially oriented to go to the right. Okay, so all we have to do to flip him around is to just go into the transform into the scale and set his x. Yeah, we're going to set his x scale to -1. Is that right? Yeah. We're going to set his x scale to -1 because his x scale is currently 1. So -1 is going to flip him the other way. So we're going to do transform local scale equals, we should be able to do that x. Transform local scale equals -1, and transform local scale x equals 1. So that should take care of left and right. So let's just try that out. And no, it didn't like directly modifying the x property. So what we're gonna have to do is create a new vector3 And we're just going to do -1 on the x, 0, 1 on the y, 1 on the z. And here, new vector 3, vector 3, 1, 1, 1. And we're going to have to remove that because we're modifying local scale. Alright. Let's play. So now he's oriented to the right. We're going to go right, we're going to go left, and now he's turned around. Okay. So we can do this. Now, your first instinct to actually flip him up and down would be to modify the Y scale. That's not going to work in this case because we actually have to rotate Pac-Man. And to do that, we are going to need to use the local rotation instead of local scale. So the other part of that is we're going to have to use the local rotation in the direction. We'll see. Okay, so we'll do transform dot local scale. First, we have to set the local scale and make sure that it actually is at 1, 1, 1, because otherwise we're going to have some really crazy things happening. Oops. 1, 1. Okay. And we're going to go ahead and copy that over to the down orientation as well. And then to rotate Pac-Man in the up position, we're going to just do transform dot local rotation equals quaternion Euler, and then we're just going to pass in angles. So we're going to do I think it's going to be around the z-axis, so we'll do 90. I could be wrong about that. Let's have a look. Okay, yeah, I was right. So we've got, okay, see, this is what I was talking about earlier. So we have to change the rotation back if we're going left and right. So let's go back and want to develop. If we go here, we're going to do transform local rotation equals quaternion Euler, and we're going to do 0, 0, 0. And for right, we're going to do that as well. And for down, we're just going to set it to 270. Okay, so that should work. So we're going to left, right, up, down. Okay, and there we go. There we have Pac-Man. Easy enough, right? Alright, so yeah, we've got Pac-Man animating, we've got him moving, we've got his orientation changing, we have a speed variable set up, Pac-Man knows the direction he's traveling in. This is all awesome. This is all great, okay? So in the next tutorial, next week, we are going to cover what are called nodes. Nodes are going to enable us to restrict Pac-Man's movement instead of using collision detection. So really, you know, what we could do, okay, is we could have Pac-Man move, and then we could constantly check collision detection, or we could check for collisions rather, and when Pac-Man hits a wall, we can make him stop if there isn't a key press in the up or down direction, right? Right here, he would have to stop, and then you would have to press the key up or down to continue moving, or Pac-Man would just sit there and do nothing. So instead of using collisions, what we're going to do is we're going to use nodes. And nodes, let's say for instance we call this a node and that a node. So let's say Pac-Man reaches this node. Okay, Pac-Man reaches that node. And then we tell Pac-Man, okay, this node has two neighbors. The neighboring nodes for this node are this node and this node. So Pac-Man getting to this node is going to need a decision as to whether to go to this node next or that node next. And that's where the key press comes in. So we go from this node to that node to that node, or from this node to this node, or this node to that node, and then from this node to that node to this node. So the nodes are going to be at the intersections, which are going to be decision points. So, and that is all I'm going to get into with nodes right now, because that is all for next week. It might be a little longer of a video because we're going to cover a lot of information. So stay tuned for that. And as always, thanks for subscribing to my channel. You guys are great. Leave comments down below if you've got questions. Yeah, if you like the video, don't forget to give me a thumbs up and a like. Oh, and for some reason, I've been getting emails about people not getting notifications with new videos being posted, and that is because YouTube has added this nifty little feature next to the subscribe button that you have to actually click on to get notifications. So you've got your subscribe button to subscribe to the channel, right? But that doesn't actually send you notifications when new videos are posted. That's what the little bell next to the subscribe button's for. So if you'd like to receive notifications of new, of new videos being posted. Sorry, I blanked out there for a second. Then go ahead and click that bell button. And before I forget, I am going to actually be making packages that you guys are able to purchase at some point. What I'm going to do is I'm going to create all of the videos. I have other tutorial series, Mario Clone and Tetris Clone, and what I'll do is I'll create a compilation of all of those videos together, and I'm going to package them up along with all of the source code, so a working project that will load in Unity, along with all the art assets and everything else, and very, very heavily commented scripts. And I'm going to be selling those on the weeklycoder.com website for anyone that's interested in purchasing those packages. The other thing that I'm going to start doing is instead of just selling those packages, I have a special treat for all my subscribers. Every month, I'll probably do this on the first of every month, I'm going to, at random, pick one of my subscribers, and I'm going to send them this entire package for free. Just give it away. So 12 times out of the year, I'm going to be sending away one of those packages for free. And I'm probably going to sell them for about $99. So you're going to get all of that value just for free, just for being a subscriber. So yeah, am I trying to keep subscribers? Yes. Am I trying to get new ones? Of course. I'm grateful for everyone that subscribes. I love doing this channel. I love doing this. But at some point I'm going to need to generate some kind of revenue with it because it eats up a lot of my time. And I like I said, I love doing this. You guys hopefully are getting a lot out of it, and I'd like to continue doing it. So let's work together. But anyways, thank you for subscribing. Thank you for liking the channel. I appreciate it when you guys come back and leave comments. And hope everyone has a great weekend. And I will see you next week.